Welcome back. Today we're talking about solving systems of equations using elimination, part 2. Let's go ahead and take a reminder on how we solve systems using elimination. So here are our steps for solving using elimination. Remember, you're going to choose a variable to cancel. Doesn't matter, x, y, z, a, b, whichever one. Multiply the entire equation by a constant only if it's needed. We're going to rewrite the system with a new equation, combine the two equations, and then substitute the resulting value into either the original equation, so remember that's important, and then solve for the remaining variable. Now let's take a look at example A. So here we are at example A. We're going to solve for x and y. Write your answer as an ordered pair. So we've got x equals 2y plus 3 and 3x plus 2y equals 11. So we notice right now they're not in standard form, or at least both of them are not in standard form. So remember, we want ax plus by is going to be equal to c. We want all of our equations to look like that. Right now we don't currently have that for one of them, so we're going to go ahead and set that up. So I've got x equals 2y plus 3. So I'm going to make sure that I've got y's and x's together on one side and constants left alone. So I'm going to subtract 2y on both sides, and that's going to end up with x minus 2y is going to be equal to 3. So that's one of my equations, x minus 2y equals 3. My other equation is going to be kept just the same, and that's going to stay 3x plus 2y is equal to 11. Now I can see here that I'm not going to have to do any multiplying because these negative 2y and positive 2y are going to cancel each other out. So I'm going to go ahead and just do that. So we've got negative 2y and positive 2y. These are going to cancel. X and 3x are going to give me 4x. I'm going to end up with 4x equals 14. Then we're going to go ahead and solve our one-step equation. We're going to draw a wall. We're going to divide both sides by 4. And we end up getting a fraction. That's okay. Fractions are our friend. We're going to reduce that fraction to simplest form. So we're going to get 7 halves. All right, so now we need to plug that answer back in. We know that x is one of the numbers in our ordered pair. So we're going to substitute that into either one of my original equations. So my either one, I'm going to choose the one up top. All right, so I'm going to go with 7 halves is going to be equal to 2y plus 3. So now I've got a two-step equation. I know how to solve those. So I'm going to draw my wall. I'm going to subtract 3 on both sides. These are going to cancel, leaving me with 2y is going to be equal to 7 halves minus 3, which is 1 half. So I've got 2y is equal to 1 half. So then my final step is to divide both sides by 2. Now obviously I can't divide a fraction, so I'm going to have to multiply by the reciprocal. The reciprocal of 2 over 1 is 1 over 2. So 1 times 1 is 1, 2 times 2 is 4, and I end up with 1/4 is equal to y. So now that I have both of my values, my answer is going to be 7 halves x and 1/4. That brings us to the end of this example. Now let's try example B. So here we are at example B, and I've got 7x plus 2y equals 24, and 8x plus 2y equals 30. We're going to solve for x and y and write our answer as an ordered pair. Now, good news, they're already written in standard form. X plus y equals c. The bad news is that we don't have anything that can cancel out immediately, but we do have constants that are the same. We've got 2y here and 2y here. So if I can turn one of them negative, then I won't have to worry very much about it. So I'm going to multiply that top equation by -1. Sure, I can multiply the bottom one by -1, but I'm picking the top. You can pick either one. So I'm going to end up with -1 times 7 is going to be -7x. -1 times positive 2y is going to be -2y. And then -1 times positive 24 is going to be -24. All right, now my other equation is going to look exactly the same as before. I didn't do anything with that. So I've got 8x plus 2y is equal to 30. So now I can combine my equations. -7 and positive 8 are going to leave me with just 1x. These two y's are going to cancel, and then -24 equals 30 is going to give me 6. So good news, x is already 6, and I figured that out right away. So now I just need to be able to plug that in. It doesn't matter which equation. I'll pick the bottom one this time because I'm feeling lucky. So we're going to put in the 8. We're going to put in the 6 plus 2y, and then we're going to solve for 30. So we got 8 times 6. 8 times 6 is, of course, 48. So we've got 48 now is equal, plus 2y is going to be equal to 30. So then we're going to go ahead and solve our equation by subtracting 48 on both sides. 30 minus 48 is going to give me -18 is equal to 2y. And then my final step is to divide both sides by 2. 2 divided by 2 is 1, or 1y, and -18 divided by 2 is going to give me -9. So then my ordered pair is +6, -9. Now let's take a look at the last example. So here we are at example C, and good news, everything is set up for us, ax plus by equals c for both of our equations. Bad news, we don't have anything that can cancel out and nothing that we can easily multiply by -1, so we're going to end up having to multiply both equations. So we're going to solve for x and y and write our answer as an ordered pair. So we could try and figure out something that 8 and 20 go into, but that doesn't sound like a lot of fun. It's a lot easier to do 2 and -5, and since one of them is negative, we don't have to worry about changing the sign on either. So 2 and 5 easily are going to give me 10, so that's where I'm going to start. So I'm going to multiply my top equation by 5. So 2 times 5 is going to give me 10, or 10x. 5 times 8 is going to give me 40y. And then 5 times 6 is going to give me 30. Now down at the bottom equation there, I'm going to multiply everything here by 2. All right, so we've got -2 times -5 is going to give me -10x. 2 times -20 is going to give me -40y. And then equals -15 is going to give me -30. All right, so now we're going to go ahead and combine our terms, or combine our two equations, and I've got some interesting things that are going to happen. So -10x and 10x are going to give me 0, so they're going to cancel out. -40 and +40y, they're going to give me 0, so they're going to cancel out. So I'm left with just 0 on this side. And then 30 and -30, they're going to cancel out, and they're going to give me 0. So I end up with an equation or a system where I've got 0 equals 0. And this is a true statement. So in this case, my system is going to be all real numbers. All real numbers is the solution. Our all real numbers is our answer to this equation, or our system, because they're equal to each other, and it is a true statement. That brings us to the end of this equation. It also brings us to the end of this example and this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.